You know how your phone can translate a sign in another language, like instantly? Or how Netflix just knows what you're in the mood to watch? Well, today we're going to pull back the curtain on that. We're going to follow the entire journey of a single machine learning model, from just a simple idea to the complex, powerful engine that's pretty much running our digital world.
So to really get this, we have to start with a huge shift in thinking. See, for the longest time, programming was all about writing these long, complicated lists of if-then rules for a computer. You know, if an email has this word, it's spam. But machine learning just flips that whole script. Instead of us writing the rules, we just feed the machine tons and tons of examples. Here's a million spam emails, here's a million normal ones, and it figures out the rules all by itself.
And you know what's crazy? This idea isn't new at all. We're talking way back in 1959. This guy, Arthur Samuel, an absolute pioneer at IBM, made a program that learned how to play checkers. It just played against itself over and over and over, and eventually it got better than he was. Just let that sink in for a second. The machine actually surpassed the person who created it. That one single idea, that a machine can learn from its own experience, that's the bedrock for everything we're about to talk about.
Okay, so what does this learning actually look like? I mean, how does a machine really learn from an example instead of an instruction? Let's break down what's happening under the hood.
It's actually this really simple, beautiful loop. First, the model makes a prediction, basically a guess. Then, it looks at the right answer and measures how wrong its guess was. Based on that error, it tweaks itself just a tiny bit to be a little less wrong the next time around. And then it just does that again, and again, and again. We're talking thousands, sometimes millions of times.
Now, the thing that makes this whole loop work is something called a loss function, and you can just think of it as the ultimate scorekeeper. It's a bit of math that doesn't just say, nope, you're wrong. It says, you're wrong by exactly this much. And the entire goal of all that training, that whole loop, is to get that loss score as close to zero as humanly, or I guess machinely, possible. It's the North Star guiding the model toward getting things right.
But you gotta be careful, because there's this huge trap in the process called overfitting. The best way to think about it is like a student who just memorizes the answers for a practice test. Yeah, they'll ace that specific test, but give them a slightly different question on the final exam, they're totally lost. Overfitting is the exact same thing for a model. It memorizes the training examples perfectly, noise and all, instead of learning the actual pattern. So it looks great in practice, but it completely falls apart in the real world.
So, here's a really important point. Not all learning is the same. Machine learning isn't just one magic bullet. It's more like a whole toolkit, packed with different kinds of algorithms, and you have to pick the right tool for the job. For instance, let's say you want to predict the number, like the price of a house, based on how big it is. You'd probably reach for something called linear regression. All it's really doing is the digital version of drawing the best possible straight line through your data points. That line shows the trend, and you can use it to make a really solid prediction for a new house it's never seen.
Okay, but what if you're not predicting a number, but making a choice? Like, is this email spam or not spam? For that, a decision tree is an awesome tool. It basically learns to create a flowchart of yes or no questions. It might ask, does the subject line have a bunch of exclamation points? If yes, go this way. Is it from someone in your contacts? If no, go that way. And after a few of these simple forks in the road, boom, it makes a final call.
And then there's the really cool stuff. What if you don't even know what categories you're looking for? That's where clustering algorithms come into play. You can just throw a mountain of data at them, say customer purchase histories, and they'll find the natural groups all on their own. They might discover a group of weekend shoppers or bargain hunters without you ever telling them those groups existed. It's like finding patterns you didn't even know to look for.
All right, so you've picked your algorithm, you've trained your model, and it's doing great. So you're done, right? Ha, not even close, because now the model's real journey is just beginning. It has to survive the gauntlet of the real world, and trust me, that's a whole different ballgame.
And this visual really drives home a surprising truth about machine learning in the real world. We get all excited about the fancy algorithm, the ML code. But in reality, that's just one tiny little piece of the puzzle. The vast majority of the effort goes into building all the plumbing around it. The massive systems for collecting data, cleaning it up, serving the model's predictions, and just making sure it doesn't break.
Yeah, that whole infrastructure is what manages the model's life after it's trained. First, it gets deployed, which means it's packaged up and pushed out into the wild. Then, it has to be monitored constantly. It's like a doctor checking its vital signs to make sure it's still healthy and making good predictions. And finally, because the world is always changing, it has to be retrained with new data to keep it from getting stale. And a huge reason for all that retraining is this thing called data drift. Look, the world doesn't stand still, right? People's habits change, new slang pops up, the economy shifts. And when the data in the real world starts to look different from the data the model was trained on, its performance starts to tank. Data drift is just a fancy way of saying the model's knowledge is out of date, and it's time to go back to school.
So, this whole journey, from a simple learning loop all the way to a massive system fighting off data drift, it might sound a little abstract, but it's actually the engine that's quietly humming along behind so much of what we do every single day.
We've seen it as a complicated process, right? From those first training loops to this giant real-world system. But okay, why should you actually care about any of this?
Because this exact same journey is happening right now, all around you, all the time. It's the silent process that keeps your email inbox clean. It's what's behind that recommendation engine that just uncannily knows your next favorite show. It's what breaks down language barriers on the fly and protects your credit card from fraud. When you understand this journey, you're really understanding the invisible machinery that's powering our modern world.
And that really brings us to the final and maybe most important question. We are getting scarily good at building these automated learning systems. The technical how is getting easier and easier. So the real challenge for all of us looking forward isn't so much how our machines learn anymore. It's about what we decide to teach them.